Assalamualaikum. I am Aisha Akhtar. Now I am going to present a paper presentation whose name is Exploring Neural Architectures and Techniques for the Typological Drivers Morphological Inflections. And the writer names are including in these slides. This presentation is designed for Mr. Najid Alim Russell sir, who is our advanced syntactic pattern recognition course instructor, and the course code is CSC 713. Let's start from the next slide. Now in abstract, first we have to know about morphological inflection. What it is. It is the process of generating varied representation of words based on several linguistic properties, and the inflection of words retain their core meanings. It differ in their word structure. So in this paper they have included in this abstract. So attention based encoder decoder approach that implement using LSTM, which acronyms long short term memory, and the transformers as the base units. Ancillary techniques that they experiment with, such as hallucination, language vector injections, sparse max loss, and the adversarial language network alongside their approach to select the related language for training. Then result they had generated on the constant as well as unconstant with the help of Sigmorphone 2020 dataset. Next, the introduction part. There have two methods. Number one, concatenative measures, then non-concatenative measures. They implemented to perform the task of morphological inflection in both the constant and the unconstant settings. Before we have talked about that things, and the hallucination, sparse max, sparse loss, adversarial language network, and the language vector injection techniques, they that prototype to improve the performance of the systems. So in this slide, we will talk about the related works. Morphological inflections can be divided into two main categories. Number one, non-neural approaches and the neural approaches. Non-neural approaches to have two stages, alignment and the rule generation. And they developed a cube time based dynamic programming approach with a greedy decoding schema. Then neural based approaches have recently outperformed the non-neural based approaches. Then the next part, methodology in this paper. They implemented four variants of sequence-to-sequence architectures to tackle the problem of MI. Primarily utilize the LSTM and the transformers to construct their model. Experiment with four techniques before I included the name. So in these sections, there have 9 subsections. Subsection 1 in figure. They prototype an elementary LSTM sequence to sequence model. They incorporated two LSTM encoders with each individual encoder taking the input as the lemma and tag respectively. Then the subsections 2 in figure. The use of attention has shown improvement in the performance of such models. Thus, they replace the LSTM encoders in the previous modules with the transformer encoder. Then section 3. In these sections, they replace the LSTM decoder with the transformer decoder. Now going to the next slide. Then the subsections 4 in figure. The final architecture they implemented in is an in transformer model. They concate the lemma and the tag and feed it to the transformer. Next, the subsection 5 incorporated hallucination techniques and observed a performance boost in their systems to help evaluate in this problem. They used this data argument techniques in this process. Each part is considered as a stem character inside the region are randomly substituted with other character without changing the overall length. Then the subsection 6 in figure. In this section, sparse max assign exactly 0 attention weight to irrelevant source tokens and impulsible hypothesis and is shown to retain sparse posterior distributions. Sparse loss is the loss typically associated with the sparse max and is known to be computationally very feasible. Then the subsection 7 in figure. They extract the representations generated at the first time step and the last time step by lemma encoder and concrete this representation. This representation is then passed through a linear layer and a softmax layer, which produce a prediction for the languages. Then they reverse the gradient while training. The subsections 8 in figure. So in these subsections, to integrate the language vector, first extract the language to vector for a particular language. They pass in it through a two-layer dense neural network. This provides as a compact representation for this vector. Subsection 9. Select the related languages and target languages pairs for training. They utilize the pre-compute features distance presence in the language to vector library. Number 4 sections experimental result. 5 submission to share in the unconstant setting and 2 the constant settings. 5 the analysis part. Approach of generating morphological inflections and encapsulated several models name that included in this slide. And the next is subsections. There have 5.1 analysis of models used, accuracy obtained on 6 languages from the Sigmorphone 2020 dataset in the unconstant setting where the languages were trained in conjunction with related languages. Related languages have been presented in their ISO 6393 code format. 5.2 subsections. Utility of adversarial language network. Accuracy obtained on 6 languages from the Sigmorphone 2020 dataset in the constant settings where the languages were trained without using any related languages. Subsection 3. Use the sparse max and sparse loss. Sparse max and sparse loss aided the LSTM encoder decoder models to a greater extent as compared to the transformer-based models. Subsection 4. Utility of language vector injection. The structural information embedded in the language vector help their model efficiency generate morphological inflection. Last slide in this presentation. Feature work sections. Not able to search through all the combinations of the techniques that were mentioned in this slide. The limitation availability of supervised data for low resource languages. Third, propose to combine the probability generate and the conclusion part. Encoder decoder based approach using both different support techniques implement which discussed before. Result for the Sigmorphone 2020 dataset. Deeper and try to present a detailed analysis of the different components. Thank you.